All right, when we try to put irrational numbers on the number line, it gets tricky because while we could exactly place rational numbers on the number line by putting equal numbers or spaced out hash marks and then pointing to an exact hash mark, that is actually impossible to do when we're dealing with irrational numbers, numbers that are not rational. So here's an example of a number that is not rational, the square root of 2. Square root of 2 is a number that has a decimal that goes on forever, but never repeats. It never repeats. So this is absolutely irrational. In fact, any square root of a non-perfect square is always going to be irrational. So 2 is not a perfect square, so the square root of it will not be rational. Square root of 9, for instance, is rational. Square root of 9 is rational. Square root of 9 is 3 because 9 is a perfect square. So since the square root of 9 is a rational number, 9 must be a perfect square, which it is. So 4 is a perfect square, 9, 16, you could think of others. Okay. 2, however, is not a perfect square. So it's going to give us an irrational root, okay? And this is certainly very irrational. So how do you put this on the number line? I mean, I could put the square root of 9 on the number line. I could put 3 on the number line. That'd be pretty easy. But how am I going to do this number? The answer is we have to estimate. We cannot do it precisely. We cannot do it exactly. All we can do is estimate and do the best we can. So we're going to round this. Let's round it to the nearest tenth. So if we round it to the nearest tenth, this is the tenths place. And so if we were to round this nearest tenth, well, 1 is less than 5. And so this 4 remains a 4. Okay? So 1.4 is a rational approximation. It's a rational approximation of a very irrational number. So I'm going to write not an equal sign anymore, but this squiggly equal sign and say 1.4. Now this 1.4, that's a rational number, and we can put rational numbers on the number line. I'll give it to you to do so right now. Okay, so now that you have been able to approximate irrational numbers by rounding off or by estimating, now I'd like to give you some more examples. Okay, so even though we can't precisely put numbers that are irrational on the number line, we can get pretty close. So let's do another example. How about, let's say that this was, 3 and this was 4. Now we can estimate, even without a calculator, we can kind of estimate where, say, the square root of 15 is. 15 is not a perfect square, and so the square root of 15 is not going to be perfect. What two numbers would the square root of 15 be between? And you don't even need to use a calculator. The square root of 15 is almost the square root of 16, and the square root of 16 we do know. The square root of 16 is 4. But this is just under that. So 4, that's the square root of 16. 3, that's the square root of 9. Do you see that the square root of 15 is somewhere between the square root of 9 and the square root of 16? And not only is it between these two, meaning the square root of 15 has to be between somewhere between 3 and 4, but do you see how close 15 is to 16? It's much closer to 16 than 15 is to 9. So it's somewhere in between, but I would say it's somewhere over here to say. Okay, so even though without a calculator it's difficult to go much further, you at least can kind of guess where it would be on this. Okay, now let's use a calculator. I'm going to type in 15, and I'm going to do the square root. And so the square root of 15 is 3.87298, and it just keeps on going. So 3.8, I mean, that's not bad for not using a calculator. Okay. So now what we're going to do is we're going to round. So let's round to the nearest tenths place. So what would this be rounded to the nearest tenths place? It would be 3.9, because you look at the tenths place and then you look to the number to the right. 7 is greater than 5. It's 5 or greater, and so 8 gets promoted up to a 9, so it's 3.9. Now 3.9, that is a rational number, and that's a number that you can put on the number line. So let's look at 9/10. If you're going to have 10 sections that you're going to make in here, how many hash marks are you going to need? Okay, so you're going to need 9 hash marks. And don't worry about doing it perfectly. Just try to space them as much as you can. So 1, 2, 3, 4, 6, 7, 8, 9. I did the best I could. Okay, so now right here is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9/10. So this right here is 3.9. Okay? Now, remember that the square root of 15 is 3.87 and all the rest. So if I were to draw this as an arrow to point to the number line, where would it be exactly? Would it be just to the left of this? Would it be exactly on this hash mark, or would it be just to the right? Since 3.87 is just shy of 3.9, I'm going to get very close to this hash mark, but I'm going to put my arrow on the left-hand side, because it's going to be just shy of 3.9. So this arrow right here is even more precise, but it's still not 100% precise. It's the best we can do with an irrational number like the square root of 15. All right, thanks.